So we take a look at this. We've got the expansion from a 2-inch pipe to a 6-inch pipe, so little d over big D. And so that'll give us a third, which is about 33. And so we look here, 33, probably about right there. We read it up, we read it over, and then we can pull out what our value is. It's 0.79. I use the equation to get that. It makes things a little bit easier, but you can use the chart and you'll get roughly the same answer. So then as we look at the second section, the 6-inch pipe, there are no minor losses there at all. The turbine is there, but any losses in the turbine will be taken up by the HP term, the HT term. And then we look at our last one, our 3-inch pipe as it's leaving. Well, there's only 2 minor losses there. We have the exit. Remember, exits are always 1. But we also have the open globe valve. So we go to globe valve, fully open globe valve. So 3 inches. It's going to be right in between those two right there. Halfway in between those will be 6.3. Now, this is the tabulated version of all those minor losses. Now, once we have that, we can go and start calculating out our total head loss equation. And as you can see here, we have the total head loss of the 2, the 6, and the 3-inch pipe. So we plug everything in that we have. These are all of our numbers from before. This is where you can check your numbers to see if you made a mistake. But you add it all up, and so our total head loss, once you do all the math, is going to be 22.5 feet of head loss due to friction. So at this point, we plug that into our energy equation, this initial equation that we wrote out. And as we plug it out, plug all those numbers in, we're going to find the head extracted by the turbine is 77.27 feet. And from there, we go to our equation. The power is going to be rho GQH. And I just noticed that this says pump. That is not correct. This is a turbine. Same equation, but we're using the turbine. So the power of the turbine is going to be rho GQH turbine. So our rho, 1.94 slugs per cubic feet, accelerated by gravity, times our flow rate, times the head the turbine provides. And that's going to give us 772.3 foot-pounds per second. We want it in horsepower. To make that conversion, 1 horsepower is 550 foot-pounds per second, which will finally give us the power provided by our turbine is 1.4 horsepower.